4, section 4.1, properties of integer exponents and scientific notation. Some properties of exponents. Multiplication of like bases means b to the m times b to the n is b to the m plus n. So if we had 2 to the third power times 2 to the 7th power, it's actually 2 to the 3 plus 7, or 2 to the 10th. Division of like bases. B to the m over b to the n is equal to b to the m minus n. So wherever the bigger exponent is, that is where that piece is going to stay. So if we had 2 to the third over 2 to the second, we're 2 to the 3 minus 2, which is 2 to the first. In hindsight also, if it was in reverse, we had 2 to the second over 2 to the third, we end up being 1 over 2 to the third minus 2, or 1 over 2 in this instance. Power rule says b to the m in parentheses raised to a power on the outside is the same thing as saying b to the n times n. So if we had 3 to the second in the parentheses raised to the third power, we actually see 3 to the 2 times 3, or 3 to the 6th power. Power of power rule says a product inside parentheses raised to an m power, m being any exponent, you split it. So it's going to be each individual part raised to that power. So if we had 2x to the third power, it's 2 to the third, x to the third. Power of a quotient. If you have a parentheses fraction inside raised to a power, you split the power into each piece. So if we had 2/3 raised to the 4th power, we end up being 2 to the 4th over 3 to the 4th. Some other rules of properties. B to the 0 power means any base raised to a 0 power is always 1. So if we see 3 to the 0 power, your answer is going to be 1. Y to the 0 power, your answer is going to be 1. 1000x in parentheses raised to the 0 power, your answer is 1. If you have a negative exponent, a base number raised to a negative exponent, you're going to rewrite it as 1 over b to the n. So if we see 3 to the negative 2, think of writing it over a 1. And we are swapping numerator and denominator. So we become 1 over 3. Now it's a positive 2. So we get 1 over 9 as our answer. If you have a quotient inside of parentheses raised to a negative exponent, the inside is what is swapping positions. So we have a over b raised to the negative n. The rule says swap the numerator denominator inside, the exponent becomes positive. So now I'm b to the n, a to the n. So if we saw 2/3 to the negative third power, you rewrite it as 3 over 2 to a positive third power, where it gives us 3 cubed over 2 cubed. Example 1. In A it says parentheses negative 2 raised to the 4th power. This is the same thing as you saying negative 2 times a negative 2 times a negative 2 times another negative 2. Notice that they are all contained in parentheses. Remember your rules. 2 negatives make a positive. This becomes positive 4, and the other set becomes positive 4, so our final answer is 16. Not to be confused with B. A and B look similar. Parentheses, no parentheses. When there is no parentheses, it says negative 2 raised to the 4th power. This is rewritten as negative 1. That's what that negative sign represents. Times 2 raised to the 4th power. So we see negative 1 times, we know that 2 to the 4th is 16 based on the previous problem. So then your final answer is negative 16. On C, it looks similar to A and B. It says negative 2 raised to the negative 4th power. Remember, this is actually negative 1 times 2 raised to the negative 4th power. So we become negative 1 times, using the previous rule, 1 over 2 to the 4th now becomes positive. We know 2 to the 4th is 16 based off part A. So we get negative 1 over 16 as our final answer. Based on the rules we studied a minute ago, remember what I said, parentheses, negative 7x, close, raised to this, anything raised to the 0 power, your answer is 1. Not to be confused with E. D and E look similar, only parentheses, no parentheses. On E, it's negative 7x to the 0 power. The negative 7 does not have the exponent. Think of it as negative 7 times x to the 0 power. So we become negative 7 times 1, because that's what x to the 0 power represents. And your final answer is negative 7. Example 2. Simplify the expressions with only positive exponents. So on A it says x cubed times x to the 5th times x to the negative 2nd. Remember, these are the rules of bases. Bases are all the same. They're being multiplied together, so you are adding your exponents. So this becomes x to the 3 plus 5 plus a negative 2. So 3 plus 5 is 8. 8 minus 2 makes it 6. Your answer, final answer, is x to the 6th power. On B, it says y to the 7th over y to the 4th. So remember, quotient rule says they subtract your exponent. So you write y to the 7 minus 4, since 7 actually is the bigger exponent. So I'm going to write it over 1. If the bigger exponent is on top, it's over 1. If the bigger number is on the bottom, then it's 1 over. So this one becomes y cubed. Now I'm going to change the problem and invert it. So I'm going to write y to the 4th over y to the 7th. The bigger exponent is on the bottom. So I'm going to write 1 over y 7 minus 4. So your answer is now 1 over y to the 3rd. On C, it says parentheses b squared, close, raised to the negative 5th power. So on this one, you can either do it one of two ways. You can first write it over 1 and swap the power so that your power becomes positive, or apply the product rule. So I'm going to apply the product rule first. So it's going to be b to the 2 times a negative 5. So you get b to the negative 10. Now, we're not allowed to have negative exponents. So think of it over 1. And you are swapping numerator and denominator, doing the reciprocal of it. So we get 1 over b to the positive 10. Example 3, it says simplify. You have 1/5 raised to the negative 3rd power minus the parentheses 2 raised to the negative 2nd power plus 3 to the 0. So we're going to treat each piece as its individual parts. So the first one, quotient raised to negative exponent. The rule says we swap numerator and denominator. Exponent becomes positive. Minus sign. We are writing it over 1 so that we know that numerator and denominator are going to swap. So that I see 1 over 2. Now the exponent becomes positive. Then the rule of anything raised to the 0 power is a 1. So 3 to the 0 is a 1. Now we're going to apply the power rules. So 5 cubed, it's 5 times 5 times 5. That's 125. I'm going to put it over 1. Minus 1 over 2 squared. That is 4. Plus, I'm going to write this as a fraction also, 1 over 1. So the reason I wrote it as a fraction is because you need to combine your like terms. In order to combine fractions, common denominator needs to be played. Since we circle our denominators and we notice that 4, so our common denominator, our LCD, has to be a 4. So I'm going to put a 4 minus a 4 plus a 4. 1 became 4 by multiplying top and bottom by 4. So the top number becomes 500. 4 already is there, so I'm just going to write 1/4. 1 becomes 4 by multiplying top and bottom by 4. So now all we have to do is add and subtract the numerators. 500 minus 1 is 499, plus 4 is 503 over 4. Example 4. It says 4x y to the negative 3rd times the parentheses 8x squared divided by 3x to the 5th y to the 2nd, close the parentheses, raise to the negative 2 power. So it's got a lot of things going on it. So the first thing we're going to do is we're going to write the first piece, 4xy to the third, negative third over a 1. And we're going to work with that piece of the problem. So first thing we're going to do is we're going to swap what is negative needs to move down to the denominator. The only thing that is shifting is your y to the negative third. So it becomes 4x over y cubed. That is the first piece. Now we're looking at the second part. It says 8x squared over 3x to the fifth, y to the second, all raised to the negative 2 power. I want to get rid of the negative 2 exponent by switching the numerator and denominator inside the parentheses. So we're going to rewrite it as 3x to the fifth, y to the second, over 8x squared. Close the parentheses, now it's a positive 2. Next thing we're going to do is we're going to apply the power rule. We're going to multiply we're going to give that power to every single piece inside. It's the power of the product. So 4x y cubed slides down. Now we become 3 squared, x to the 5 times a 2, y to the 2 times a 2, divided by 8 squared, x 2 times a 2. So you give the power of 2 to every single piece inside the parentheses. We're going to slide down again. 4x over y cubed times, now 3 squared is a 9. X, 5 times 2, that makes it x to the 10th power. The y, you see 2 times 2 makes it y to the 4th. Divided by 8 squared is 64. X to the 2 times 2 makes it x to the 4th. So we're at this point. First thing we're going to do now, combine any numerator-like terms and denominator-like terms. So I'm going to write it as 4 times 9. It's going to become x to the 11th because there's an x with another 10, makes it 11. Y to the 4th, all divided by 64. X to the 4th, I lined it up underneath the x to the 11th, and y to the 3rd, I lined it up underneath y to the 4th. We can reduce. The number 4 is a factor of 64. So 4 goes into 64 16 times. So I reduced it there. The x's, the bigger numbers in the numerator. So you have 11 on top, 4 on the bottom. So 11 take away 4 means we have 7 in the numerator. So we have a 9 x to the 7. The y's, or your yo-yos. There's 4 in the numerator, 3 in the denominator. So 4 take away 3 means we have 1 in the numerator. All divided by what was left over, which was 16. Example 5, scientific notation. So in the past, you were told place a decimal point at the end of a big number, and then you loop backwards, counting the number of humps until you get to the first and second non-real number. I'm going to change it up a little bit. We're going to look at our problem. It says 75 million. I'm going to draw a line between the 7 and 5. That is where your decimal point is going to go. So we have 7.5 times 10. Now, our exponent, looking at the line, you count the number of place values you have gone. So there's a total of 7, so your exponent is 7. Now, decimal values at the beginning. So 0.000000001. Think of this as a virus. That's the size of a virus underneath a microscope. The decimal point's in front of the value. So the line is going to go after the first and second non-zero number, which means it's going after the 1. So your number becomes 1 times 10. Now you're counting from the decimal point, all the values until you hit that line. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are -9. So if we are in going to scientific notation, so going to scientific notation, big money is going to be a positive exponent. Virus size is going to be a negative exponent. Example 6, going to standard form. So it's the reverse. Now I'm going to show you the trick. Before you were told to write 1.25 and then you loop from the decimal point 11 places to the right and then fill in with zeros. And make it easier on you. Your exponent is 11. It says 1.25 times 10 to the 11. The exponent is 11. Count the number of decimal places after the decimal point. There's 2 decimal places. So you're going to do exponent minus decimal places. That is the amount of zeros at the end. So 11 minus 2 means we have 9 zeros. So you're going to write 1, 2, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And you have your expanded form. The second one where it says 4.35587878 times 10 to the negative 8. It's going to be one different. It's going to be one different. You're going to use the absolute value. So exponent is negative 8. You're going to go number of decimal places before. So it's going to be exponent, the absolute value of your exponent, minus decimal place before, which is always 1. That's the number of zeros in front of the expansion. So we see negative 8. So negative 8, absolute value is going to be positive, minus 1, which means we have 7 zeros. So we're going to put 1, 2, 3, 4, 5, 6, 7. There's my 7 zeros. I'm going to put my decimal point in front of it because that's being expanded out. And then attach the number 4, 3, 5, 5, 8, 7, 8, 7, 8. And there's your